and welcome to my Physics 2212 Lab 1 presentation. The purpose of Lab 1 is to explore fundamental properties of magnetism and charge and design an experiment out of regular household items. The regular household items used in this lab are pieces of clear Scotch tape, a pen, and a ruler. For the first part of the experiment, we prepare U-tapes by swiftly ripping tape off of another base tape, which creates a charge. And then we charge a plastic pen by rubbing it against wool, making it negatively charged, and we put it up to the U-tape to see what charge it has. If the U-tape is positively charged, then the U-tape will attract to the pen. If the U-tape is negatively charged, the U-tape will repel the pen, and if the U-tape is neutral, the U-tape will be attracted. We found that the U-tape attracted to the pen, and in the future experiment, we will see that two U-tapes will actually repel each other, meaning the U-tapes are positively charged. In the second part of the experiment, we prepare two U-tapes, and we suspend the first U-tape in the air and hold the second U-tape underneath. The tapes have a repelling effect on each other, causing the top tape to be raised 0.022 meters in this experiment from the top tape's original position. And now we are tasked with finding the charge of the top tape. The fundamental properties we use to find the charge of the top tape will be Newton's second law, which is F equals ma, and physics principles of charge and magnetism, specifically the force of electrical forces. The data in this experiment that we found are the length of the tape we used is 19.6 centimeters or 0.196 meters. The mass of the tape being 1.96 times 10 to the negative 10 kilograms, and the distance between the two tapes in the second part of the experiment being 0.022 meters. And then we have constants. So within the calculations of our lab, in order to find the magnitude of the charge of the electron, we used Newton's second law. And since the top tape had zero acceleration during experiment 2, we can safely say that the force of gravity and the electrical force are equal to each other. So we use the electric force formula and the force of gravity formula, and we isolated the Q variable, which is the charge in the electrical force formula, and solved for it. And we found that the magnitude of charge is 1.01 times e to the negative 9 coulombs. And to calculate excess charge, we divided the electrical force by the charge of electrons, and to calculate the number of atoms on the tape, we divided the area of the tape by the atom length constant, which is 1 times 10 to the negative 10. And then to find the ratio of electrons to atoms, we divided the excess charge by the number of atoms. And here's my code for everything in the previous example, which will also be linked in the description. And what assumptions we had to make for this experiment for calculation purposes, we assumed that both tapes had the same magnitude of charge, and we treated both tapes as a point charge. And charge was evenly spread out on the piece of tape. And additional questions that are asked in this lab is, what if electrons had positive charge and protons had negative charge? What change about the observations you made with your tapes and other charged objects? The outcome would be exactly the same, but it would just be flipped. So the tape would be negatively charged and the pen would be positively charged, but the charge in every other outcome would be exactly the same, just negative versus positive. And why is it important to handle the charged tape as little as possible? What happens when charged tapes come into contact with your hands or other objects? Charge would be rubbed off into my hand or other objects, causing the tapes to have less charge and creating a more imperfect outcome in our lab.